Hi everyone, so today we're going to be doing a discrete and a continuous random variable transformation example. And so let's begin. So the first question says that we have a PMF of a random variable x, which is over here, and we want to find the PMF of y equals x to the power of 4. Now since this question gave us a PMF and we want to find a PMF, this means that x is a discrete random variable. And now with discrete random variables, the first thing we want to check is if our transformation is a one-to-one function. Now here we need to see if y equals x to the power of 4 is one-to-one. And if we look at the graph of this function, it looks like this. And if I draw horizontal lines going through it, the horizontal line intersects with the graph at the same point twice. Therefore, y equals x to the power of 4 is not one-to-one. Since our transformation is not one-to-one, we can't use the series of steps that I have outlined in a previous video. Therefore, we're going to have to figure out the PMF case by case. To do this case by case, we need to first figure out our support of y. To figure out the support of y, all we have to do is take the support of x and plug it in to our transformation. So, to figure out our support of y, all we have to do is y equals negative 1 to the power of 4, which equals 1. And then we do the next number, y equals negative 2 to the power of 4, which equals 16. And then the last one, y equals negative 3 to the power of 4, which equals 81. Therefore, our support of y is 1, 16, 81, and then it goes on. Now that we have our support of y, we're going to do this case by case. So for the first case, we're going to use the number 1. I'm going to set the PMF of y with 1 inputted into it equal to p of y equals 1, and then y in this case is equal to x to the power of 4, so I'm going to do p of x to the 4 equals 1, and then this is equal to the PMF of x, where I find the fourth root of 1. I'm going to be finding the inverse of my function. So I get the fourth root of 1 is x equals 1 plus the PMF of x equals minus 1. And when I plug in x equals 1 into my given PMF of x over here, I get 1/2. Plus, when I plug in x equals minus 1 into my given PMF of x, I get 1/2 again. And this whole thing is equal to 1. Now, I can do this series of steps using the number 16. So p of y with 16 is equal to p of y equals 16, which equals to p of x to the power of 4, which equals 16. Now I'm going to find the fourth root of 16, which equals x equals 2, plus p of x equals minus 2. And when I plug x equals 2 and x equals minus 2 into my given PMF, I get 1/4 plus 1/4, which equals 1/2. And now I'm going to do the same thing with 81. And this keeps going on. You can also find a closed form for this PMF, but it's also okay to write it out this way as well. It depends on your instructor. Now we're going to move on to our next question. And this question says that we have a PDF of our random variable x, and we want to find the PDF of our transformation y equals x cubed. Now, since this question gives us a PDF and we're trying to find a PDF, this means this is a continuous random variable question. And with the continuous random variable question, we're going to be using the Jacobian technique. So the first step is to find our support of y. Now, to figure out the support of y, we just need to take our support of x and plug it into our given transformation. So 0 to the power of 3 is equal to 0. And 3 to the power of 3 is equal to 27. So this is going to be our support of y. Since it is continuous, we're going to be using our inequalities. Now we're going to find the inverse of our transformation, y equals x cubed. So we have y is equal to x cubed, which means that x is equal to y, the cube root. And now we can find our Jacobian, which is basically just our dx over dy, which will just be 1/3 y to the negative 2/3. And we also have to find the absolute value of this. And the absolute value of this will just be the same thing. Now we can just plug this into the series of steps I have outlined in a previous video. So our PDF of y is just going to be equal to our PDF of x where I input my inverse into my PDF of x, and I multiply it by my Jacobian. And this is equal to this because I plugged in my inverse into my given PDF. And I multiply this by my Jacobian. And this is equal to 1/27. And I just have to write my support of y. So this is my PDF of y.